Although P can be quite powerful and easy to use, the downside is that it's something new to learn and master. It's easier than writing MapReduce programs, but it's not the lingua franca that SQL is. Some folks at Facebook developed a Hadoop runtime component that allows anyone who is already fluent with SQL to leverage the Hadoop platform right out of the gate. They created Hive, which allows SQL developers to write Hive query language HQL statements that are similar to standard SQL statements. HQL is limited in the commands that it understands, but it's still pretty useful. HQL statements are broken down by the Hive service into MapReduce jobs and executed across the Hadoop cluster. For anyone with an SQL or relational database background, this is all going to sound very familiar. You can run your Hive queries in a few different ways. From a command line interface known as a Hive shell, from a JDBC or ODBC application leveraging Hive, JDBC or ODBC drivers, or you can use the Hive Thrift client to communicate with the Hive server. This is much like any database client that runs on a client machine or in the middle tier of a three-tier architecture. You can use the Hive Thrift client within applications written in C++, Java, PHP, Python, or Ruby, much like you can use these client-side languages with embedded SQL to access a database such as Netezza or DB2. Hive looks very much like traditional database code using SQL. But because Hive is based on Hadoop and MapReduce operations, there are a few key differences. First, Hadoop was initially intended for long sequential scans, and because Hive is based on Hadoop, you'd expect queries to have a very high latency. So, Hive would not be appropriate for applications that need very fast response times, as you would expect with databases such as Netezza. Secondly, Hive is read-based, so it's not appropriate for transaction processing involving lots of inserts, or for SQL-based data transformations using insert from select.